In EICAS Lab, the rapid control prototyping activity is carried out through three sub-modes. The RCP on field that manages the overall experimental trial executions, the slow motion that allows, by means of the slow motion tool, the offline repetition of experimental trials executed on field for advanced debugging and tuning purposes, and the SIM RCP that allows a very easy switching from real-time to the simulation environment in order to perform further analysis with the same control algorithm and configuration experimented on field. We first illustrate the rapid control prototyping on field. Starting from the control system architecture designed in EICAS Lab and through a real-time scheduler and multi-threading and multi-core programming techniques, EICAS Lab generates the real-time software code to be transferred on a PC platform with a Linux real-time operating system directly connectable to the plane to be controlled. Such real-time software code is able to configure and manage interfaces of the PC platform, offering fully customizable libraries of built-in interfaces and protocols. It is able to configure the real-time scheduling of the overall control activities and to execute in real time the RCP trial, piloting the plant through a specific professional tool, the RCP Manager, including an easy and friendly graphical user interface and offering capabilities for controlling and managing the RCP process in real time, for enabling diagnostic reports with the aim to warn about possible faults or problems arising during the RCP trial execution, for visualizing on the screen the dynamic behavior of the variables of interest for real-time monitoring, for recording on the PC disk all the variables of interest for a subsequent post-analysis through the POST tool, or for performing the offline repetition through the slow motion tool, and for commanding and modifying parameters during the real-time execution. We now illustrate the slow motion sub-mode. During the experimental trial execution, it may be difficult to monitor in detail the variables of interest or to follow and understand the execution of the control algorithm because the access to the variables may be limited. In EICAS Lab, this problem is faced by means of the slow motion tool. During the execution of the first sub-mode, the rapid control prototyping on field, a slow motion recording function is available, able to automatically record on the PC disk all the plant inputs computed by the controller and the plant outputs and the host commands data sent to the controller. When you have concluded your experimental trials, you can run on the RCP platform the slow motion that, starting from the recorded data, works like a moviola. The application software runs in like real time, but it is exactly the same one that ran during the experimental trials. The control functions receive as input the recorded outputs of the actual plant and the recorded host commands instead of the simulated ones. Then the recorded experimental trial performed by the actual plant controller is completely repeatable in EICAS Lab using the same control code used on field, with the difference that now the process can be performed in slow motion and, if useful, may be run step by step by using a debugger program for advanced debugging and tuning purposes. All the working variables of the control software may be recorded and then analyzed by means of the POST tool available in EICAS Lab. We now illustrate the SIM RCP sub-mode. It can be useful after an experimental trial carried on with the RCP on field to come back in a simulation environment in order to perform further analysis with exactly the same control algorithm and the same control configuration experimented on field. Such configuration during the experimental trials can be slightly modified respect to the one of the first operative mode. The Sim RCP sub-mode allows to easily switch from RCP on field to the simulation environment, maintaining all the data that you have set during the experimental trial. You can then easily switch again from the Sim RCP to the RCP on field in order to carry out the RCP trial on the improved control algorithm. We finally list the tools that help you performing the rapid control prototyping control design phase in the rapid control prototyping operative mode. First, the master tool allows to manage the ACASLab projects and runs, for each operative mode, suitable and powerful software tools necessary to develop, test and validate the overall control algorithm. The Sim Builder tool allows you to implement your control strategy, to schedule your control functions, to define the hardware input-output interfaces, and to configure all your trial executions. The RCP Manager tool allows you to interact with the real-time application and to follow the system variables trend during the RCP trial's execution. And through the MPI CPO Manager tool, you can perform model parameter identification, specifically devoted to identify the parameters of the plant model of your control, and control parameter optimization, specifically devoted to optimize the control algorithm parameters. The Slow Motion tool allows the repetition of experimental trials executed on field, and you can post-process any data obtained during the trial execution using the Post tool. Finally, the Sim RCP tool allows to perform like real-time simulations of the same control algorithm and configuration experimented on field. This webinar stops here. The next webinar will deal with the rapid control prototyping operative mode exploited for the Amazing Ball use case. Thank you for your attention. For any other information, please visit www.acaslab.com.